not tomorrow. It's not very hard to say. The test is this Friday, right? This Friday. So I gotta make a note to get you your practice test. It's online, but I gotta print them out for you too. Okay. I'll try to get those to you tomorrow. I need to do that.
Mr. Shaver, didn't you say we weren't going to have a practice test for this chapter?
No, I said you would not have a take-home test on this chapter, which is a graded assignment. Graded assignment. Were you talking to me or are you talking to me? Between us, you got it? I think you're good. I listened to it. All right, who's up first time? Maddie Gibbs. We're looking at this particular problem right here. The instructions are find the inverse f minus 1 of x if f of x is this problem right here. Okay? And my answer is going to look like this. We expect it to be piecewise defined as well. And what we're going to find is that many students have big time troubles with the if part of the inverse. Most students are able to knock out the inverse pretty easily. This part, we'll do the first one. If we had y was 3x plus 1, call that the original. To do the inverse, what do I write down next, Maddie?
X equals 3y plus 1.
So we swap the x and y's, because that's the idea of an inverse. You swap your x and y. You go back where you were. So we get this y alone, and we get?
Y equals x minus 1 over 3.
So we have x minus 1 over 3 is the inverse part of the 3x plus 1. And to do the other one, we start with y is the square root of the quantity x plus 15. Then we draw a line because it's different. And we get?
X equals square root of y plus 15.
Keep going.
And then square both sides. X squared equals y plus 15. Y equals x squared minus 15.
So excellent job of those relatively easy inverses. You found both of them correctly. And so you're almost done with the problem. Now, to get this correct is a little bit challenging, and I think so that you know what you're doing, graph it. So we're going to graph the original, not on the calculator, by hand. We're going to graph the original. So the original in black, the inverse in red. Okay? And so the graph is we're gonna knock it out like this. And I'll do a little bit of this. I'll do the first part and have you talk through the second part. First part is I have to find 3x plus 1. The y-intercept is 1. The slope is from there up 3 over 1. It's a line. But I'm doing something. Why did I dot that portion, Maddie?
Because it's going to be.
No?
Or, yeah, x is less than 1.
So only when x is less than 1, I really should have an open circle there. Should have an open circle. So we have this line when x is less than 1. Now, if you think about y is square root of x, and we replace x with x plus 15, we're replacing x with x minus 15, we're moving it 15 back, way back here. It's up 1 over 1, up over 4 up 2, over 9 up 3, over 16 up 4. So it's coming in like this, and then it's curved, but it looks pretty much like a straight line. It just has a little bit of downward concavity, and this point's there though, because when we plug 1 in, the square root of 16 is 4. So what is the value of this point right here? What's coordinates to this point, this key spot?
1, 4.
1, 4. If the original curve has a big deal at 1, 4, where's the inverse going to have a big deal? Anybody?
4, 1.
4, 1. The xy swap from original to inverse. So 4, 1 is going to have a big deal. And if we do the inverse function, one way to do it is by reflecting it over the line y equals x. So the inverse of this line should, instead of going through 0, 1, it's going to go through 1, 0 instead of 1, 4, 4, 1. So it's going to look like that, and straight back, and I'll actually dot it. And the inverse of this curve, instead of going through negative 15, 0, it's going through 0, negative 15, and it ends up coming up through this point. It's dotted, and then it should hit there and fly up that way. It's supposed to be moving off to the right somewhat. 4, 1. So, Matt, I give you first shot at it. What do I write right there?
X is greater than or equal to, no less than or equal to 4.
And what do we write here?
X greater than 1. No, 4, sorry.
4. It's
4,
4
yeah.
again. The key value is 4. If I'm less than 4, I'm along the line. If I'm greater than 4, I'm along this curve. I'd probably put the equals with that. But what you wrote was fine because it worked for both of them. It's the same point. You could, we don't want to put it for both. But since this had the less than with the line, I'm going to put the less than with the line there. And we describe functions in terms of x. But remember, these x values are sort of the y's from the original. So when the y was bigger than 4, we were along the curve. When the y was less than 4, we were along the line. So we would call x because it's the inverse. That is a question type that I always put on the first test of the year. It can be done reasonably quickly if you really know what you're doing, but it's a good challenge. It's just a real good test problem. It can be done in a few minutes if you know what you're doing, and will baffle you otherwise. There'll be another one coming up. Okay, let's go to 24. Who's up next?
Jonathan.
Jonathan, 24.
Let f of x equal x squared when x is greater than 1, and g of x equals the square root of x. Then A, show that f of g of x equals x when x is greater than 1, and g of f of x equals x when x is greater than 1.
Okay, so we're going to do that pretty easily. Okay, we want f of g of x, and so we're going to write f of g of x, and you just told me that g of x was the square root of x, so I substitute square root of x for g of x because they're the same. This is a little bit harder, Jonathan. What's f of the square root of x? F of something is its squared, so f of the square root of x would be
X.
It would be x. It would be the square root of x squared, which is x, which is what they wanted. This one's a little bit harder. When we do g of f of x, you just told me that f of x was x squared. So what's g of x squared? It's the
Square root of x squared.
which is what?
Plus or minus x.
No, it's a function. It's only returning one value. It's not returning
Okay.
two. It's the absolute value of x,
No.
which in this case is x. Why can I say in this, for this problem, the absolute value of x is x?
X is greater than 1.
Yeah, because we're dealing with x greater than 1. So we show what they want. Okay? That's part A. Keep reading, part B.
Show that f and g are not inverses by showing that the graph of y equals f of x and y equals g of x are not reflections of one another about y equals x.
Okay. So here's the line y equals x. And the f is x squared, goes through 0, 0, goes through 1, 1, it goes through 2, 4. It looks like this parabola. And the g of x I'll do in red is the square root curve. And was the red the reflection of the black across the blue line? No, it's missing the bottom half of the parabola. So it's not inverse. These are not inverse functions. Part C, I think, says Is there a contradiction here?
Do parts A and B contradict one another? Explain.
Yeah. Do they? Is there a contradiction there, or is everything okay? Because in A, we had f of g of x is x, g of f of x is x, which is normally what it means to be an inverse. In part B, we said it's not inverse. But they don't contradict each other. How come?
Because A doesn't deal with negatives.
Correct. A restricted the domain to something that passed the horizontal line test. We actually restricted it to just this portion right here, x greater than 1. And it was the inverse on that portion. So we talked last week, like with the sine curve, we have to restrict the domain to have an inverse. They had restricted the domain. They could have a less rigid restriction. They could have gone with x greater than or equal to 0 and still would have worked. But they restricted the domain, so everything's good. Awesome. Now 27, I'm just going to put a star by it. A definitely test you on this problem. I think it's a great problem because it requires understanding what's going on with functions. And if you understand it, you can do it in about 50 seconds. But a lot of students don't understand it, and then they try to do something that takes them minutes and minutes and minutes, and they get confused and it messes them up. Who's up, Thomas?
Partial.
Arshel, number 27.
So let f of x equal 2x to the third plus 5x plus 3. Find x if f inverse of x is what?
So we're finding x so that f minus 1 of x, the inverse of inverse function when you plug x into it, gets you 1. Many students try to find the inverse. Just like Maddie did on the first problem. They draw a line, swap the x's and y's, and Arshel, what's next? I'm trying to get y alone. We're in trouble, aren't we? We can't get to y alone with a y cubed and a y. Now, there are some cubic equations where you can get y alone. It's very rare, though. This is just very difficult for us to do. It's not an algebraic technique you've been taught at all. We don't know how to get y alone. And so some people are saying, I can't come up with the inverse function. But there's a much easier way to understand this. Look at what's going on. F and f minus 1 are inverses. Think about doing f minus 1 and then f. If I plug x into this, I get an answer. And when I plug the answer in, what do I get at the end?
X.
X. We're back to the original because they're inverse functions. Now they want to find the x such that f minus 1 of x is 1. They want the x so that when we plug it in here, it creates 1. So how do I find it? Do you see, Arshel?
You plug 1 into the y one?
We plug 1 into what?
The y?
Nope. I could put, well, actually you're correct. You're correct. If we plug 1 into here for this y, it's going to give us the x that works. That's exactly right. Another way to think of it is we know that 1 plugged into f gets us our answer. So we just plug 1 right in here. Plug 1 right into the function f, and we get 2 plus 5 plus 3. It comes out as 10. So what's the x got to be? 10. The answer is 10. Since I had written this out, Arshel was totally correct to say, just let the 1 be this y and see what x is. But even if we hadn't done that, we could realize that 1 into f gets us 10. So just put 1 into f. Put 1 there. So therefore, we need f of 1, which is 2 times 1 cubed plus 5 times 1 plus 3, which is 10. And the answer is 10. Okay. All right, back up front. Who's got 35?
Oh,
Eliana, 35.
Given, sorry, Given that theta equals the inverse tangent of 4/3, find the exact values of sine of theta, cosine of theta, cotangent of theta, secant of theta, and cosecant.
So you're gonna notice some trig review thrown at us right here. And I think almost everyone in American school learns the mnemonic SOHCAHTOA for right triangle trigonometry, where you have to be aware of where your angle is, and the legs are called opposite and adjacent, the hypotenuse is called the hypotenuse. And we're gonna find these 5 things. I think the other thing you have to remember to do these problems is that the cosecant of theta is the reciprocal of the sine. The secant of theta is the reciprocal of the cosine. Those can easily get confused, but the cosecant is reciprocal of sine, secant is reciprocal of cosine. And this problem becomes super easy, Eliana, if we simply draw a triangle. It doesn't have to be to scale. Call the angle theta, and now we need the angle whose tangent is 4/3. So what can I label along this triangle if theta is the angle whose tangent is 4/3?
You can go opposite is 4.
One opposite is 4.
One next to it's 3.
One adjacent to is 3.
My hypotenuse 5.
So it's a 3, 4, 5. The hypotenuse that follows is 5. Awesome. So the sine of theta is,
4/5.
and the cosine is
3/5.
cotangent is the reciprocal of the tangent. If the tangent's 4/3, secant,
5/4.
no,
Oh, no, 5/3.
it's the reciprocal of the cosine. And last one,
5/4.
awesome. Don't let him bother you, okay? Don't let him, okay? Luckily this webcam has another lens pointing backwards, so you can just review that one. Everything's good. 39.
Sandra?
Sandra, 39.
The sine of 2 times the inverse cosine of 3/5.
They want us to simplify that. And so we have to remember some things. We have to remember the sine of A plus B, sine A cos B plus cos A sine B. I don't know if you remember those. You have to know that if we go with A plus A, we have sine A cos A plus cos A sine A, so it's 2 sine A cosine A. I'll also review the fact that cosine of 2A is cosine squared A minus sine squared A. If you replace cosine squared with 1 minus sine squared, you can do the cosine of 2A that way. If you replace sine squared with 1 minus cosine squared, I'm obviously reviewing that super fast. Those are on your stimulus reaction sheets. You need them to do this problem. You actually need this one. We're going to call this A. So this can be thought of as 2 sine A cosine of A, which in this case, A was the angle whose cosine is 3/5. Angle whose cosine is 3/5. So I'm going to draw, Sandra, a triangle. I'm not trying to make it to scale. I'm going to call an angle A here. It's the angle whose cosine is 3/5. What can we label?
The adjacent side is 3 and the hypotenuse is 5.
Awesome.
So the opposite is 4.
So I'm circling the opposite because we derived that from the others. We knew that it was the angle whose cosine is 3/5. So the adjacent is 3, the hypotenuse is 5. That yields, by Pythagorean theorem, Pythagorean triples, if you know them, you should know that one, that that's got to be 4. And so, Sandra, finish this next line. Give me this next line right across.
2 times.
Look at what it's asking for. It's asking for the sine of the angle whose cosine is 3/5. This is the angle whose cosine is 3/5. What's the sine of that angle? It's just 4/5. Then it asks a silly question like, what's the color of a white house? What's the cosine angle whose cosine is 3/5? Final answer?
24/5.
24 what?
Fifths? No, just kidding, 25ths.
24 25ths. Okay, we have a fifth of a fifth of 2 4 3. 2 sets of 4 sets of 3. So a fifth of 24 24 fifths. Awesome. One more like it. 41, and then we'll do 3 problems out of the other lesson, and then you have a decent amount of time to work today. Who's got 41?
Mikey.
Mikey, 41.
A is the cosine of the inverse tangent of x.
Okay, what's B?
Tangent of the inverse cosine of x.
I think I only did one of them in the other class, but it's good we're doing both. Let's draw the triangle. We're going to call this theta. I'm going to call this theta. It's the angle whose tangent is x. I'm not trying to draw the scale, but we can label it how, Mike?
The opposite is x. And then the adjacent is 1.
So he made an excellent recognition that x is the same as, come on, x over 1. X is the same as x over 1. We want to think of ratios when we're doing trigonometry. So angle whose tangent is x, it's the same as the angle whose tangent is x over 1. Now there's a harder thing to do now. What's the hypotenuse then, Mikey? What's the hypotenuse?
X squared plus 1.
No?
Square root of x squared.
Yes. So you're able to figure out using the Pythagorean theorem that the hypotenuse squared of x squared plus 1. Call it c. You have 1 squared plus x squared is c squared, so c is the square root of 1 plus x squared. There it is. Okay? So what's the cosine of the angle whose tangent is x over 1?
Adjacent, which is 1, over hypotenuse, which is the square root of x squared plus 1.
That's excellent. I'm really happy with that answer. Some teachers would want you to rationalize, and you get this answer. But I'm happy with that, okay? Because I would argue this is simpler than that, okay? Now, to do, who's up on the next one, Thomas?
Nate.
Nate, very similar problem, but we're calling this A. How do I label it?
The adjacent is x and the hypotenuse is 1.
So what's the opposite side going to be then?
The square root of x squared minus 1. Or 1 minus x squared.
Which one?
1 minus x squared.
Right, it's hypotenuse squared minus a squared. Perfect. So what's the tangent of the angle whose cosine is x?
Square root of 1 minus x squared over x.
Perfect. Okay. Jonathan, stop that video. We're going to do a few more problems on the second video so I can post them